Hi, I'm Mark Walters with the Z-Wave Alliance, and I'm here at the Z-Wave Alliance Fall Summit 2014 in Southern California. I'm here with David Zima from RF Laboratories. RF Laboratories is one of the premier RF consulting firms in the country. And David, I know that RF Laboratories works with a lot of different Macs and PHYs, and that you get to play with everybody's radio. And I'd just like to ask you why you think that Z-Wave is being as successful in the marketplace today as it is.
Sure. Well, there's a couple reasons. I think one of the main reasons is when Z-Wave was conceived, it didn't try to be all things to all people. The physical layer is using a very elegant biphase Manchester encoding scheme. It's simple. It's simple to employ in terms of hardware, but on the mesh network side, on the Mac side, the engineers who conceived it didn't try to solve all problems in the world. It's like the old Dremel commercial that we can do this and you see a drill, and we can do this and you see a grinder, but then there's a hammer and we can't do that. And they were really smart when they wrote the Z-Wave Mac and Stack. They didn't try to solve all engineering problems. Z-Wave is one of the best solutions for home automation, for light industrial, for that reason. On the other side, from an engineering standpoint with radio, there is an advantage to operating in the frequency range that Z-Wave operates, 900 megahertz. The propagation is more advantageous than 2.4 gigahertz. The ITU, the International Telecommunications Union, chose 2.4 gigahertz intentionally so radios wouldn't work at too great a distance, so they wouldn't interfere with one another. But of course, they didn't anticipate some of the problems that low-power 2.4 gigahertz radios and meshes are experiencing. I see much less of that. In the 20-some years I've done this, I see much less of those problems with Z-Wave, which is why it's one of my number one choices for a radio solution and my number one choice for a mesh network.